Hi, everyone. What answers did you get for the first question? Okay, good. 9 is correct. Shivani, can you explain?
Yeah, so if you add up, so you start from 2 and then you go to 4 and then you go to 6 and then 8 and then 10 and eventually get to 18, and if you add those up you get 90. And yeah, and that's how much the entire thing, that's how many cans there are in the entire thing, which is what it says in the problem.
Good. Yep. So that's correct. That's one way of solving it. So we know that we start with 2, and each row has 2 more than the previous one. So 2 plus 4 plus 6 and so on. And we want the sum to reach 90. So if we add up to 18, which is 9 rows, we get 90. So good. This is one way. Did anyone else use any different approaches to solve this?
Well, I kind of used a different route. I used the formula S of n is equal to n times a of 1 plus a of n over 2. And I substituted what I knew, and then I kind of had to figure out 18. But I already knew that because like the trick word, like 2 plus 18 is 20, 4 plus 16 is 20, 6 plus 14 is 20, 8 plus 12 is 20, so that's 80, and then plus the 10 is 90. So I plugged that in and it all checked out.
Okay, good. Yeah, I think that also works. But let's look at a similar way, but let's try to build up to reach that maybe in a slightly easier way. Okay, so let's say we're adding these numbers. So we start with 2, 2 plus 4, 2 plus 4 plus 6, and we want this to reach 90, right? Let's see if we can find a pattern in these sums. Okay, so 2 is just 2. What is 2 plus 4?
6.
Okay, 2 plus 4 plus 6?
12.
Okay, 2 plus 4 plus 6 plus 8?
20.
Okay, and let's do one more. 2 plus 4 plus 6 plus 8 plus 10.
30.
Okay, do you see any pattern here so far?
It's going up by the number that was newly added.
Good, yeah, it is. Let's try to look at, so that still won't help us to get the sum of more of them faster, right? So we want maybe a different way of saying, okay, so in this case, we added up the first number and we got 2. When we took the first 2 numbers, we got 6. When we got the first 3 numbers, it became 12. One way to maybe look at this is, let's try to write these as the product of 2 numbers. What can we write 2 as a product of? So something times something else.
1 times 2.
Okay, good. What about 6?
3 times 2.
Okay, let's say 2 times 3. What about 12?
2 times 6.
Another one?
Or 3 times 4.
Okay, what about 20?
4 times 5.
30?
5 times 6.
You see a pattern now.
Yeah. Yes.
Okay, what is the pattern here?
So when you're multiplying it, it's basically going up like 1, 2, but then the next number, it has the last number that the other number had, which is 2. So 1 times 2, the next one is 2 times 3, and it's basically going up by 1.
Good. So let's write this in a different way. So what are we doing here? We're basically summing the first n even numbers, right? So if I'm adding 2 plus 4 plus 6 plus 8 plus 10, I'm adding up these even numbers, right? So this is the sum of the first n even numbers is what in terms of n? So this is the first 1, first 2 is 2 plus 4, first 3 is 2 plus 4 plus 6.
Is it just S of n? Or
Close. So
never mind.
we want to write it in terms of n, right? So we want this, so for instance, in this case, n is 3. What is the sum here?
12.
Good. So if n is 3, we write it as n times something, right? So n
Times 12.
times n plus 1, right? So, so see, like for instance, in this case, we have the first 3 even numbers is going to be 3 times 4. The sum of the first 5 even numbers is 5 times 6. Let's try this out. The sum of the first 4 even numbers should be what?
$20.
Good. And because that is n times n plus 1 here is 4 times 5, right?
Mhm.
Which matches up with what we saw. 2 plus 4 plus 6 plus 8 does give us 20. Okay, so now let's go back to the original question. We know we're adding up 2 plus 4 plus so on, and we want the sum to be 90. So what is that the product of? 2 consecutive numbers, right? We know it'll be in the form n times n plus 1.
9 times 10.
Good. So 90 is equal to 9 times 10. So can we get the answer from that directly?
Yeah. Not, it'll be 9 because that's the first number.
Good. Yeah. So because 90 is 9 times 10, and we know that the sum of the first n even numbers is n times n plus 1. So if it's 90 is 9 times 10, the sum of the first 9 even numbers is 9 times 10. This is a useful formula to use, but you can also think about it as you kind of develop this pattern. Another way of actually getting the same kind of formula in a different way, what if we divided all the numbers by 2? So the sum of 2 plus 4 plus 6 is actually just 2 times what? The sum of what?
6.
6, good. Can we write what is that the sum of? So we just remove the factor of 2 from each of them, right?
2 plus 2 plus 2.
That's also equal to 6, but let's write it this way, 1 plus 2 plus 3, right? So instead of 2 plus 4 plus 6, I can write this as 2 times 1 plus 2 times 2 plus 2 times 3, right? Or instead, that's the same thing as saying 2 times the sum of 1 plus 2 plus 3. Does that make sense?
Yes.
Okay, so now what is the sum 1 plus 2 plus 3? Is there a formula for this? So if I add up the numbers 1 plus 2 plus 3 up to some number n, these are called triangular numbers. Does anyone know this formula?
Isn't that the one I was saying earlier? The n times, well, that one has the a though. I don't know if we, the a time a of 1 plus a of 2, a of n over 2.
Yeah, good. So that is the same. I mean, you can derive the formula from that approach. That's, I think, for any generic arithmetic sequences, I think what you're referring to. But if you kind of simplify it for this case, it's always just n times n plus 1 over 2. This is a useful formula since sometimes the sum of 1 plus 2 plus 3 up to some number occurs commonly, or is sometimes more needed. So once you have this n times n plus 1 over 2 is this, when we look at this, this is 2 times that, right? Because we're saying all the even numbers, it's always 2 times 1 plus 2 plus 3 or 1 plus 2 plus 3 plus 4. So we see how these kind of match up, right? In this case, the sum is just n times n plus 1 over 2. And when you look at the first n even numbers, it's just that times 2. So n times n plus 1. Okay, any questions on this? Okay, let's move to the second one. Okay, 900 is correct. Nidhi or Neil, can you explain?
Yeah, so after reading the question, I made like an equation where x is equal to, and then parentheses, x over 9 plus x over 10 minus 10. And then that's per hour, that per hourly rate with both Brenda and Brandon together. And so you have to multiply it times 5 for because they worked 5 hours for the chimney, and just solve the equation, and you get x is 900.
Okay, good. Yeah, this is one way. So this would be 5 times 19x over 90 minus 10 equal to x, or 19x over 18 minus 50 is equal to x. So x over 18 is equal to 50. Or x, so x is equal to 900. So basically this algebraic way is saying, so x is the total number of bricks in the chimney. So if Brenda takes 9 hours to build the chimney alone, then per hour, Brenda puts in x over 9 of the bricks, and Brandon puts x over 10 of the bricks. So adding them up is how much they would do together per hour, but it reduces by 10 bricks an hour. So we subtract that out. So this is how much they do together per hour. And we know they finished the built chimney in 5 hours. So multiplying by 5 must equal to the total number of bricks in the chimney. So once we have this equation in x, we can simplify and solve for x, and we get x is 900. Okay, so this is one way of doing it. We can also do a similar approach without using any algebra. Any ideas how you might do that? Okay, so what fraction of the chimney does Brenda finish in an hour?
One-ninth.
Like, yeah,
Good. What fraction of the chimney does Brandon finish in an hour?
a tenth.
Okay. So what fraction of the chimney do they finish together in an hour if you added them up?
19 over 90. Sorry.
Okay, good. So it is 18 over 90 when they build it together. But if you just add up the fraction that they each build individually in an hour.
Oh no. I said 19.
Oh, okay. 19 over 90. Good. Yeah. So this is just 1/9 plus 1/10, right? Okay, so we can simplify this as 9 over 90 plus 10 over 90. Okay, so if you just added up their rates, they should finish 19 over 90 of the chimney in an hour. But when they actually work together and build the chimney, what fraction of the chimney do they build together per hour?
Would it be 5 times 19 over 9? 90. Or 90?
Let's see. How did you get 25?
No, I was kind of just guessing at it.
Okay. So let's go back and look at the question at this part, right? Working together, they build the chimney in 5 hours. So if it was just them working together, and if they each worked one did 1/9 of it in an hour, the other one did 1/10. So combined, they did 19 over 90 in an hour. It would take them 90 over 19 hours to complete it, right? Which should be less than, so if they did 19 over 90 per hour, it would take them 90/19th hours, which is a little bit less than 5 hours, right? If you look at 19 times 5 is 95. So this is less than 5 hours if their kind of output didn't slow down, right? The problem is that when they work together, they're talking, and now their combined output is dropping by 10 bricks per hour. Okay, so they're together, their output should have been 19 over 90. But instead, what is it? Because we know they can build the chimney together in 5 hours. So what fraction of the chimney do they build together in 5 hours? So the same way that we did the 1/9 and 1/10. So what is the fraction of the chimney that they build together in an hour?
Is it for Brenda like 4/90 and then Brendan 5/90? Oh wait, no, that's no.
Close. Okay, let's go back. So okay, we know that they built 1/9 and 1/10 of the chimney each hour, right? Okay, together they build the chimney in 5 hours, right? So by the same logic, they should do they're building 1/5 of the chimney in an hour, right? Instead of in each of them would take them 1/9 and 1/10 of a chimney in an hour. Together they built 1/5 of the chimney. The problem is that together if they should have done 19/90 of the chimney, instead they only do 1/5. So what is 1/5 with the denominator of 90? How do we compare the two? So 1/5 is equal to what over 90?
I believe 18.
Good. Okay, 18/90. So combining their individual rates, they should have done 19/90 in an hour. Instead, they only do 18/90. So how much slower are they producing the chimney per hour?
So the 10 bricks per hour is the 1/90th of the chimney.
Good. So 10 bricks per hour is 1/90th of the chimney. So what's the total chimney?
90 times 10, which is 900.
Good. So in this way, we didn't use any algebra. We just thought about, okay, so Brenda takes 9 hours to build it. So in an hour, Brenda does 1/9 of the chimney. Brandon takes 10 hours to build the chimney. Brandon does 1/10 of the chimney in an hour. So together they should build 19/90 of the chimney in an hour. Instead, they actually only build 18/90 of the chimney, or 1/5 of the chimney in an hour. So basically their output is slowed by 1/90th of the chimney every hour. And we also know that's equivalent to 10 bricks per hour. So if 10 bricks is 1/90th of the chimney, the whole chimney is 90 times 10 or 900 bricks. Any questions on this? Okay, let's move to the last one. Okay, any ideas on this one? Okay, let me fill in this and then we'll start looking at it. Okay, so we have this magic square. And we know 3 of the numbers in the magic square, the top 2, and we know this one. And our goal is to find this number, the number in the top left corner. Okay, so any ideas on any of the other values? Can we fill any number in this grid?
The bottom left square could be 114 because 19 plus 96 is 115. So
good. Okay, so this is the first thing we can do here is look at this row. We know that the sum of, so the rule in the magic square, the sum of any row, any column, or any diagonal is the same. So this sum is the same as this sum, is the same as this sum, is the same as this diagonal, and this diagonal all have the same sum. So if we know that the sum of these three numbers is the same as the sum of these three numbers, this number is the same in both, right? So the sum of these two has to be the same as the sum of these two. These two we can see add up to 96 plus 19 is 115. If this is 1, this is 114. Okay, good. So we have one step is done. Let's see what we can do next. Can we fill in anything else now? Let's try to use the same trick.
You could try to fill in the middlemost because you have two numbers of it.
Okay, good. Which middle one? This,
Like the very center.
the very center? Okay, yeah, ideally, if we could fill this in, this would be really useful. But the problem is that if we take this one, we don't have two others in its row, right? To use. Let's look at maybe this square right below it. Is there a way we could fill this one in? So think about this diagonal. We know that this diagonal sum must be the same as this column sum. What does that tell us? What is common between the two?
Oh, okay. So it would be, sorry, it would be, so for 114 plus 96 is 210. So then 210 minus 19 is 191. So that would be the bottommost.
Okay, so the same idea, right? We can fill one more in. Can we fill anything else in the same way?
The middle one, the right middle,
Okay, what is that?
that would be 219.
Why?
Because, or sorry, it would be 209. Because it would be equal to 210 plus that y, that middle value that we don't know. So
Good. Okay, so it's the same idea here, right? So think about the sum of this row and the sum of this diagonal. Or you could even take the sum of this row and the sum of this column. We know they have the same sum because of this rule. Now, if these two, this column and this row have the same sum, but they also share this number, right? Both of these are the same in the row and the column. So that means that the sum of these two numbers must equal the sum of these two numbers, which actually must equal to the sum of these two numbers. So this pair adds up to 210. This pair adds up to 210. So this pair must also add up to 210. That gives us 209 here. Okay, good. Anything else we can fill in with the same trick? So now the problem is we could fill this one in if we knew this one, right? We could kind of write it in terms of x, and that's actually one way of doing this. We can do it algebraically, but let's try first to do this without any algebra. So let's think about what else we can do. So we've kind of used this trick to what we can do. Let's think about it in a different way. We know the rows all sum to the same thing. Let's say all the rows sum to some n is the number that each row adds up to. What is the sum of all the numbers in the whole 3 by 3 square? So let's say each row, column, and diagonal sums to n. So what is the sum of all the numbers?
Would it be? I'm not really sure, but is it n squared or not?
Close. Yeah, n times 3, right? So n is the first row, n is the second row, n is the third row, right? Yeah, so I'm defining the row sum rather than if you take all of the numbers and divide it by 3, that would be a row. So the sum of the entire of all the squares is 3n. Does that make sense?
yes.
Okay. Does that help us know what is the sum of these 6 numbers, the 6 numbers that we have filled in here? We know all the numbers in the whole square
So the
add up to
6,
3n.
the 6 would be 2n,
Good. Why 2n?
because it's the 2/3 of the box and all of the boxes 3n. So, yeah. And then I found out that the 6 numbers add up to 630. So if we did 630 is equal to 2n, I think that's how you find n.
Mhm.
So 630 divided by 2 is 315.
Okay.
So then we know each row, column, and diagonal sums to 315. And then we can solve for x because it would be 315 minus the 19 plus that would be 115, which is 200.
Good. So 200 is correct.
Okay.
But let's just go over one thing in between. So you said that it's 2n because we're looking at 2/3 of there are 6 of the 9 squares. That's close, but that's not always true. So it doesn't mean that any 6 squares I pick here will always add up to this. I think there is a selection of 6 squares if I pick maybe these 3, these 2, and this 1 wouldn't add up to 2/3 of the whole grid. So why do particularly these 6 add up to 2/3 or 2n here? Okay, so we said the whole thing adds up to 3n, right? So these 6 squares are the whole thing except for which ones?
One diagonal of the middle, top left, and then the bottom right.
Good. And what do we know about the sum of this diagonal?
It's equal to n.
Good.
We know is 315, but at that point we didn't.
Yes, good. Yeah, so that's the way we know for sure that these 3 plus these 3 add up to 2n, because it's actually 3n is the whole grid minus this diagonal is n. So these 6 add up to 2n. So you have to be careful because if I pick some other 6 in this grid, it doesn't necessarily need to be 2n. There are a lot of 6 that do add up to 2n, but this is nice because it's the whole 3 by 3 grid except for this diagonal, right? So you know that 3 by 3 grid is 3 times the sum of any row. This is equal to the sum of a row. So the sum of all the numbers we have filled in is 2 times a row. So now we can add them all up. So as Nidhi did, she got 630. So that's twice the sum of a row. So one row must sum to 315. Now we can look at either this column or this row, and we know these two add up to 115. So 315 minus 115 gives us the number here being 200. And now if you want, you can fill in all the remaining numbers. You know that each row now has to sum to 315. So you can fill in these and you can actually double check every row, every column, and every diagonal. And you'll see they all actually would sum to 315, which is this really nice property of this magic square. Any questions on this? Okay, that's it for today's class then. We'll see you all next week.
Thank you.
Thank you.
Thank you.